NENOMATICA, where mathematics meets YouTube excellence. Welcome to our lesson on factoring algebraic expressions using the difference of squares formula. Today, we'll work through two examples step by step to help you master this important algebraic technique. Let's start with our first example. We want to simplify the expression 2 minus 2 times the quantity x minus 3 squared. Let's solve this step by step. First, we'll factor out the common factor of 2 from both terms. According to the distributive property, we can factor out the 2 to get 2 times the quantity 1 minus the quantity x minus 3 squared. Next, we recognize that what we have inside the brackets is a difference of squares. We can rewrite this as 2 times the quantity 1 squared minus the quantity x minus 3 squared. This follows the pattern a squared minus b squared. For step 3, we'll simplify each factor inside the brackets. For the first factor, 1 minus the quantity x minus 3 simplifies to 1 minus x plus 3, which equals 4 minus x. For the second factor, 1 plus the quantity x minus 3 simplifies to 1 plus x minus 3, which equals x minus 2. Now, let's look at our second example. Here we have the quantity x plus 1 to the fourth power minus the quantity x minus 1 to the fourth power. Let's tackle this expression. In step 1, we'll rewrite this as a difference of squares by noting that a fourth power can be written as a square of a square. So we have the quantity x plus 1 squared minus the quantity x minus 1 squared. For step 2, we'll apply the difference of squares formula where a equals the quantity x plus 1 squared and b equals the quantity x minus 1 squared. This gives us the product of two factors. The first factor is the quantity x plus 1 squared minus the quantity x minus 1 squared. And the second factor is the quantity x plus 1 squared plus the quantity x minus 1 squared. Now for step 3, we need to simplify each factor. Let's start with the first factor. This is again a difference of squares, so we can apply the same formula. We get the quantity x plus 1 minus the quantity x minus 1 multiplied by the quantity x plus 1 plus the quantity x minus 1. Simplifying these, we get 2 multiplied by 2x, which equals 4x. For the second factor, we expand the squares and combine like terms. We get x squared plus 2x plus 1 plus x squared minus 2x plus 1, which simplifies to 2x squared plus 2, or 2 times the quantity x squared plus 1. Finally, in step 4, we multiply the results from step 3 to get our final answer. 4x multiplied by 2 times the quantity x squared plus 1 equals 8x times the quantity x squared plus 1. Let's summarize what we've learned. When factoring expressions, always look for common factors first. Then, identify any patterns like the difference of squares formula. A squared minus b squared equals a minus b times a plus b. We solved two examples. 2 minus 2 times the quantity x minus 3 squared, which factored to 2 times the quantity 4 minus x times the quantity x minus 2, and the quantity x plus 1 to the fourth power minus the quantity x minus 1 to the fourth power, which factored to 8x times the quantity x squared plus 1. For practice, try factoring 9y squared minus 1, x to the fourth power minus 16, and 125p cubed minus 8q cubed. In our next topic, we'll explore the sum or difference of cubes and polynomial grouping. Let's look at two examples that showcase these techniques. Let's start with our first example. We need to factor the expression 3x to the fifth power minus 48x y to the fourth power. Our first step is to identify and factor out any common terms. Looking at our expression, we can see that 3x is a common factor in both terms. So we factor out 3x, giving us 3x times the quantity x to the fourth minus 16y to the fourth. For the second step, we need to examine what's left inside the parentheses. Notice that x to the fourth minus 16y to the fourth is a difference of squares. We can rewrite this as x squared minus 4y squared. Now we can apply the difference of squares formula. U squared minus v squared equals u minus v times u plus v. In our case, u is x squared and v is 4y squared. So we get x squared minus 4y squared times x squared plus 4y squared. But we're not done yet. We get x squared minus 4y squared times x squared plus 4y squared. But we're not done yet. Looking at the first factor, x squared minus 4y squared. We can see that this is also a difference of squares. We can factor it further as x minus 2y times x plus 2y. So our final factored form is 3x times x minus 2y times x plus 2y times x squared plus 4y squared. Let's move on to our second example. This time we need to factor b squared, y minus b squared minus a squared, y plus a squared. Our first step is to rearrange and group the terms to identify patterns. We can regroup our terms as follows: b squared y minus b squared minus a squared y minus a squared. This grouping helps us see a pattern more clearly. Now, let's factor out the common terms in each group. From the first group, we can factor out b squared, giving us b squared times y minus 1. Similarly, from more clearly, now, let's factor out the common terms in each group. From the first group, we can factor out b squared, giving us b squared times y minus 1. Similarly, from the second group, we can factor out a squared, giving us a squared times y minus 1. Notice that y minus 1 appears in both terms. We can factor this out, giving us y minus 1 times b squared minus a squared. Finally, we can recognize that b squared minus a squared is a difference of squares. Applying the difference of squares formula, we get b minus a times b plus a. So our final factored form is y minus 1 times b minus a times b plus a. Let's summarize what we've learned about we need to factor the expression 4x squared plus 2x minus 9, y squared minus 3y. The first step in factoring this expression is to group similar terms together. We'll use the grouping rule, which states that we can rearrange the terms to group them effectively. We can group the terms with x squared and y squared together, and the terms with x and y together. This gives us open parenthesis 4x squared minus 9, y squared close parenthesis plus open parenthesis 2x minus 3, y close parenthesis. Looking at the first group, 4x squared minus 9, y squared, we can recognize this as a difference of squares. The rule states that u squared minus v squared equals open parenthesis, u minus v close parenthesis times open parenthesis, u plus v close parenthesis. In our case, we can rewrite this as open bracket open parenthesis 2x close parenthesis squared minus open parenthesis 3, y close parenthesis squared close bracket plus open parenthesis 2x minus 3, y close parenthesis. Now we can apply the difference of squares formula to factor the first group. Using the formula u squared minus v squared equals open parenthesis, u minus v close parenthesis times open parenthesis, u plus v close parenthesis, we get open parenthesis 2x minus 3, y close parenthesis times open parenthesis 2x plus 3, y close parenthesis plus open parenthesis 2x minus 3, y close parenthesis. You notice anything interesting? We can see that open parenthesis 2x minus 3, y close parenthesis appears in both terms. This means we can factor it out using the distributive property. We get open parenthesis 2x minus 3, y close parenthesis times open bracket open parenthesis 2x plus 3, y close parenthesis plus 1 close bracket. Simplifying inside the brackets, we get our final factored form. Open parenthesis 2x minus 3, y close parenthesis times open parenthesis 2x plus 3, y plus 1 close parenthesis. And that's our answer for the first example. Now, let's move on to our second example. We need to factor the expression x squared plus 10, y minus y squared minus 25. For this expression, our first step is to rearrange the terms. We'll use the rearrangement rule to group related terms. We can rewrite this as x squared minus open parenthesis, y squared minus 10, y plus 25 close parenthesis. Looking at the expression inside the parentheses, y squared minus 10, y plus 25, we can recognize this as a perfect square trinomial. When we have an expression in the form y squared minus 2 times y times b plus b squared, it can be written as open parenthesis y minus b close parenthesis squared. In our case, y squared minus 10 y plus 25 can be rewritten as open parenthesis y minus 5 close parenthesis squared. Now we have the expression x squared minus open parenthesis y minus 5 close parenthesis squared. This is again a difference of squares, where u is x and v is open parenthesis y minus 5 close parenthesis. Using the difference of squares formula, we get open bracket x minus open parenthesis y minus 5 close parenthesis close bracket times open bracket x plus open parenthesis y minus 5 close parenthesis close bracket. The final step is to simplify each factor. In the first factor, x minus open parenthesis y minus 5 close parenthesis simplifies to x minus y plus 5. In the second factor, x plus open parenthesis y minus 5 close parenthesis simplifies to x plus y minus 5. So our final factored form for the second example is open parenthesis x minus y plus 5 close parenthesis times open parenthesis x plus y minus 5 close parenthesis. Let's summarize what we've learned in this lesson. First, we learned how to group terms to isolate differences of squares. Second, we applied the formula u squared minus v squared equals open parenthesis, u minus v close parenthesis times open parenthesis, u plus v close parenthesis for differences of squares. And third, we factored out common factors to simplify expressions. We successfully factored two complex expressions, 4x squared plus 2x minus 9, y squared minus 3y, which factor to open parenthesis 2x minus 3, y close parenthesis times open parenthesis 2x plus 3, y plus 1 close parenthesis, and x squared plus 10, y minus y squared minus 25, which factor to open parenthesis x minus y plus 5 close parenthesis times open parenthesis x plus y minus 5 close parenthesis. We have the expression a squared plus b squared, all squared, minus 4a squared b squared. For our first step, we'll recognize that this expression has a special form. It looks like a difference of squares. If we let capital A equal a squared plus b squared, and capital B equal 2ab, then our expression becomes a squared minus b squared. Now, we can apply the difference of squares formula. A squared minus b squared equals a plus b times a minus b. In our case, a is a squared plus b squared, and b is 2ab. Let's simplify what's inside each parenthesis. In the first factor, we have a squared plus b squared minus 2ab, which is the perfect square trinomial for a minus b squared. In the second factor, we have a squared plus b squared plus 2ab, which is the perfect square trinomial for a plus b squared. So our final answer is a minus b squared times a plus b squared. This is a beautiful result showing how the original complicated expression simplifies to a product of perfect squares. Now, let's move on to our second example. We have the expression 1 minus 4x squared minus y squared minus 4xy. First, let's rearrange this expression to better see its structure. We can rewrite it as 1 minus the quantity 4x squared plus 4xy plus y squared. Looking at the term inside the parentheses, we can recognize it as a perfect square trinomial. 4x squared plus 4xy plus y squared equals 2x plus y squared. Next, we can rewrite the expression as 1 squared minus 2x plus y squared, which gives us a difference of squares pattern. Now, we can apply the difference of squares formula. A squared minus b squared equals a plus b times a minus b. In our case, a is 1 and b is 2x plus y. Finally, let's simplify each factor. The first factor becomes 1 minus 2x minus y, and the second factor becomes 1 plus 2x plus y. So, our final answer for the second example is 1 minus 2x minus y times 1 plus 2x plus y. Again, we've simplified a complex expression into a product of two binomials. Let's summarize what we've learned in this video. We've seen how to work with expressions involving perfect squares and differences of squares. The key algebraic identities we've used are a squared minus b squared equals a plus b times a minus b, and a squared plus or minus 2ab plus b squared equals a plus or minus b squared. These factorization techniques are powerful tools that help simplify complex algebraic expressions. Practice applying these formulas to different problems to become more familiar with recognizing these patterns. We'll factor the expression 3x squared minus 27y squared. In our first step, we notice that both terms share a common factor of 3, so we can factor it out. We get 3 times the quantity x squared minus 9y squared. Now we observe that the expression inside the parentheses, x squared minus 9y squared, can be factored further. This is a difference of squares pattern. Remember, a difference of squares has the form u squared minus v squared, which can be factored as u minus v times u plus v. In our case, u is x and v is 3y. So, x squared minus 9y squared becomes x minus 3y times x plus 3y. Let's move on to our second example. We want to factor 4x to the fourth power minus 4. First, we notice that both terms have a common factor of 4, so we can factor it out. This gives us 4 times the quantity x to the fourth minus 1. Now, we need to factor x to the fourth minus 1. We can see that x to the fourth is actually x squared squared, and 1 is 1 squared. So this is also a difference of squares pattern, where u is x squared and v is 1. Applying the difference of squares formula, we get 4 times the quantity x squared minus 1 times the quantity x squared plus 1. But we're not done yet. The factor x squared minus 1 can be factored further because it's also a difference of squares. So x squared minus 1 equals x minus 1 times x plus 1. Substituting this back, our final answer is 4 times x minus 1 times x plus 1 times x squared plus 1. Let's look at our third example. We need to factor x squared minus y squared minus 2x plus 1. This looks more complicated, but we can rearrange the terms to identify patterns. First, let's group the terms involving x squared minus 2x plus 1. This forms a perfect square, trinomial equal to x minus 1 squared. So our expression becomes x minus 1 squared minus y squared. Now we have a difference of squares pattern again. Here, u is x minus 1 and v is y. Using the difference of squares formula, we get x minus 1 minus y times x minus 1 plus y. Let's simplify each factor. The first factor becomes x minus y minus 1, and the second factor becomes x plus y minus 1. So our final factored expression is x minus y minus 1 times x plus y minus 1. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.